In this video we're going through 2022 paper 1 question 5 and it's differentiation and algebra. We're given g of x equals x squared minus 1 over x and we're asked to find the first derivative of g of x, g dash x. What I recommend doing before you actually differentiate is rewriting 1 over x. Remember that 1 over x is 1 over x to the power of 1. And instead of having the x to the power of 1 on the bottom, you can put x to the power of 1 on the top and just change the sign of the power. So 1 over x to the power of 1 is the same as x to the power of minus 1. And when it's in this form, it's much easier to differentiate. If you differentiate x squared, you get 2x to the power of 1. Here I bring the minus 1 in front, so I get minus times minus 1. And I decrease the power by 1, so it goes from minus 1 to minus 2. If I want to tidy up the second term here, minus by minus gives me plus, and x to the power of minus 2 is the same as 1 over x squared. So this is your final answer for the first part of question 5. In B part I, we're given f of x, which is a cubic equation. And we're told that one of the factors of f of x is x plus 1. We're asked to find the three values for which f of x is equal to 0. Or in other words, we're asked when does this curve cross the x-axis. When f of x equals 0, that basically means find the roots. So we're looking for the three roots of this equation. In order to find the roots, we first need the factors. We have one of the factors, and since we know one factor, if we divide the factor we have into the cubic, that'll give us the remaining factors. So really we just have to do some long division here. I'm going to divide x into 2x cubed, and I get 2x squared. Then I'm going to multiply 2x squared by each of these, and I'll get 2x cubed plus 2x squared. Then I change my signs, so I get a minus and a minus. The x cubes will cancel, and minus 21x squared minus 2x squared gives me minus 23x squared. Then I take down the next term and I start the process all over again. X into minus 23x squared gives me minus 23x. Now we multiply this term by each of these, we get minus 23x squared, and we get minus 23x. And then I'm going to change my signs and subtract. So this becomes a plus, and this becomes a plus. My x squareds will cancel, and I have 40x plus 23x, which is 63x. And finally, I'll take down the last term, which is a 63. And x into 63x is simply 63. You multiply 63 by each of these, and happy days, you get 63x plus 63. If we change those signs, then everything cancels and we're left with 0. So we've verified that x plus 1 is in fact a factor of this cubic. But more importantly, I know that if I divide x plus 1 into the cubic, I get 2x squared minus 23x plus 63. That means that one factor is x plus 1, and the other two factors come from this quadratic. So if I multiply x plus 1 by this quadratic, I'll get the cubic. And the x plus 1 will give me one of the roots, and the quadratic will give me the other two roots. So I know that x plus 1 multiplied by this quadratic will give me the cubic. And I want to solve this now. I want to let this equal to 0 and find the three roots. So what I've done is factorize the quadratic. If you factorize your quadratic, whatever method you're using, you end up with 2x minus 9 times x minus 7. So the three factors of the original f of x are x plus 1, 2x minus 9, and x minus 7. We let each factor equal to 0 and we isolate x in order to find the three roots. The three roots of this cubic are 7, 9 over 2, and minus 1. In B part 2, we're asked to find the range of values of x for which f dash x is negative. Now, if we're asked for a range of values, then obviously our answer needs to be an inequality. And we have f of x. Remember that if f of x is the cubic curve, then f dash x represents the slope of the curve. You'll notice here, the first thing I think you need to do here to visualize what's going on is to sketch yourself a curve. It's a plus x cubed, which means that it's this shape. It goes up first and then it goes down. We know that the roots are minus 1, 9 over 2, and 7. So I'm just roughly sketching where it crosses the x-axis here. I want to know when is f dash x negative. Remember that f dash x, the first derivative, represents the slope. So I want to know when is the slope of this curve negative. Now I can clearly visualize that. The slope is negative when the curve is going downwards or when it's decreasing. Clearly, from the maximum point to the minimum point, the slope is negative. So I want to work out what is the x value here, and what is the x value at the maximum, and what is the x value at the minimum. The x value from the maximum to the minimum, that is the range of values where the curve is decreasing, where the slope is actually negative. So what I'm going to do here is I'm going to work out the maximum point and the minimum point. And whatever those x values are, that's the range within which the curve is going downwards. As you can see, like sketching a cubic curve in order to understand this question is vital. Like it'd be really hard to figure out what to do if you hadn't sketched the curve. So f of x is here and I've already worked out my first derivative. Remember that in order to get the turning points, you let the first derivative equal to 0 and you solve it. So I'm going to take it from here. We're going to try and find the maximum, where the maximum point is and where the minimum point is, and those x values will give me the range when the curve is decreasing. So remember, in order to find the turning points, you let the slope of the curve equal to 0. Now what I decided to do was divide everything by 2 here, just to make the numbers a bit smaller, so that at least the numbers are reduced here. The question said to leave your answers to 2 decimal places, so that was a good indication that obviously I need to use the minus b formula to solve this. So I wrote out my a, b and c. You go to your maths tables and you get your minus b formula, and if you sub into that, a turning point exists when x is 1.14 and a turning point exists when x is 5.86. Now let's just go back and look at the sketch of our cubic curve and consider what this means and how we're going to write down our answer. So based on what we've done so far in B, we worked out that the curve crosses the x-axis at -1, at 9/2 and at 7. We've also worked out that the maximum point is when x is 1.14 and the minimum point is when x is 5.86. And the question is, when is f dash x negative? Now obviously, so in other words, when is the slope negative? Obviously the slope is negative when the curve is decreasing. And we can see from our sketch, it decreases from the maximum point to the minimum point. So to get the range of values of x, it's when x is greater than 1.14, but when x is less than 5.86. In other words, if I take any x value between these 2 points, then the slope is negative. So this is your final answer for B part II.